Hello everyone, welcome to NEET Edge. In today's video, we will be solving an important question from the chapter Circular Motion. So let's start. The question says, a ball is released from rest from point P of a smooth semi-spherical surface as shown in the figure. The ratio of the centripetal force and the normal reaction on the ball at point Q is A, while angular position of point Q is alpha with respect to point P. Which of the following graphs represent the correct relation between A and alpha when the ball goes from Q to R? So, in this question, first of all, we will make a free body diagram. So, there is a semi-spherical vessel and the ball is released from point P to point Q. Here, there are two real forces acting on the ball. One is mg, which is the weight of the ball, and the second is normal. In the question, it's mentioned that the vessel is smooth, which means the friction is absent here. So we will not consider it. Mg will be vertically downward and normal will be towards the center of the vessel. Now in the question, it's mentioned that this angle is alpha. If this is alpha, then this will also be alpha according to alternate interior angles. Now this will also be alpha according to vertically opposite angles. Now since this is 90 degree, so this will be 90 minus alpha. Now we will take two components of mg. One is mg cos 90 minus alpha, which will be equals to mg sin alpha. The second is mg sin 90 minus alpha, which will be equals to mg cos alpha. So we got its two components. Now since the ball is released from point P to Q, so by applying energy conservation, the potential and change in potential energy will be equals to change in kinetic energy. So from point P to Q, mgh will be equals to half mv square. Since the ball is dropped from P to Q, so mgh, which is the potential energy, will be converted into kinetic energy at point Q. So mm cancel, g, h is the vertical separation between P and Q, which will be equals to the perpendicular component of radius, which is equals to r sin alpha is equals to half v square. V is the velocity at point Q. So 2gr sin alpha is equals to vq whole square. Now we know that the centripetal force, which is the main driving force for a circular path, is equals to mv square by r. Now in this question, centripetal force is not equals to normal because centripetal force is the net resultant inward force. So here the net resultant force in the inward direction is n minus mg sin alpha. So here Fc is equals to n minus mg sin alpha, which is equals to mv square by r. Here v is velocity at point Q. So Fc is equals to n minus mg sin alpha is equals to m v q whole square upon r. So n minus mg sin alpha will be equals to m. We got the value of v q square as 2gr sin alpha. So we will put here 2gr sin alpha upon r cancel. So n will be equals to 3 mg sin alpha. Now in the question we have to find the relation between A and alpha, and A is the ratio of centripetal force and normal force. So A is equals to centripetal Fc upon normal n. A is equals to Fc upon N. Fc is equals to m v square upon r, and N is equals to 3 mg sine alpha. M upon r, v square is equals to 2 gr sine alpha into 1 upon 3 mg sine alpha. Now mg sine alpha, mg sine alpha cancel out, r cancel out. So A will be equals to 2 upon 3. A will be equals to 2 upon 3. So it is a constant. It means the value of A does not depend on alpha. It will remain constant. If we look at the options, then third option will be the right answer.